So this is on a high-resolution study of non-supercellular tornadoes. So we have a pretty successful simulation of an MCS, an aligned vortex, and then we take that simulation and nest it down to a higher resolution, and we forecast mesovortices. A lot of literature is showing that mesovortices are the key circulations that have to do with tornadoes in QLCSs. And so, using that 400 meters simulation, we nest down to 100 meters to look at just one of the long-lived mesovortices to try to look at the tornadogenesis of the case. So first we looked at the origin of the mesovortex. We get this surge in the gust front, and so that sets up a situation where we get cyclonic vorticity here and anticyclonic vorticity here. The cyclonic vorticity strengthens rapidly as kind of these trajectories, which I call trajectory 2, come into it. And these ones have a lot of streamwise vorticity, and as the thing strengthens, you get more and more from trajectory 2. So that's kind of showing maybe one reason why it's strengthening. It's also a way of kind of looking at occlusion of a mesovortex. So then if you kind of zoom in on this mesovortex, and you look up here at a time height plot of vertical velocity and vertical vorticity, you see that there's several pulses in vertical vorticity at the low levels, and one of them, V2, is tornado strength and is a lot longer lived than these ones. And that's also associated with this really strong low-level updraft. So there's a ton of stretching and vorticity going on here above the circulation. So we wanted to look at kind of how this is happening, how you're getting pulses like this. So I looked at how the V2 forms, and it turns out that you can track these surges in the RFD, and they're very coherent features. They'll last for 10 minutes before they actually make it into the mesovortex. So you can track them they come down, and then they'll meet up with old surges that have already come around. And when you get this meeting of this easterly and westerly flow, boom, you get developing tornado-like vortex. And then this kind of configuration here with the really strong convergence between the RFD and the RFD actually, but it's just converging back on itself, creates a really strong updraft along this area. So and that's this low-level updraft up here. And that helps to kind of strengthen and deepen the tornado-like vortex. And so we look just to verify that. We look here and see that you've got two surges. You get the TLV RFD surge meeting up with old RFD surges that are coming back around. So it kind of just suggests that to make a tornado in this situation, the main important thing is just these RFD surges. So there's not really it's not like a clash of air mass or anything at this level. It's just that the RFDs are, I think it's even mechanically being driven around, meeting back up with themselves.